Hello friends, in this session today, let's understand an interesting useful concept, Snowflake partitions, the cluster keys and partitions. When we perform data loads on any table in Snowflake, there is something called Snowflake service layer. If you remember in the architecture class, we learned there are three different layers: storage, service, and the application layer. The service layer analyzes the incoming data. It understands the volume of data, type of data, and the columns, and convert the data, or simply say split the data into chunks or partitions, and each partition of size 50 MB to 500 MB. Each partition of size basically somewhere between 50 MB to 500 MB. It does automatically. So each partition of this table is called a micro partition. Each partition, we call it as a micro partition, a new technical term for us. For example, assume a table with multiple rows, then row 1 to 10 can be one micro partition, 11 to 20 can be another micro partition, and so on. It continues. So based on the new data inserts, over time, we keep inserting updates, deletes, and perform some streaming activities, CDC, change data capture, etc. The Snowflake service layer reanalyzes the data, perform compressions, and once again repartition it. Remember, all these activities are done automatically. Okay, here is the problem. Yes, it is done automatically. But the service layer, Snowflake service layer, has to do it over the background. So it takes some additional time. It's expensive. So instead, today we are focusing on how to automate this task and do the repartitioning, of course, internally, efficiently, by creating something called as a cluster key. So remember, partitioning of table is performed using specific clustering key. Clustering key is either a single column or a set of columns. We call it composite key, or it can be an expression, like for example uppercase column text. It can be an uppercase column text, or it can be a substring, or anything it can be. A table with clustering key defined is considered to be clustered. Whenever you define a table with a cluster key, we call that particular table as a clustered table. Remember that. We'll understand now how to implement these clustering activities today. So clustering keys are not intended for all tables due to cost, because clustering means we need to divide the data, right? So division of data do have an extra cost element. So clustering, when to go for clustering, when not to go for clustering, let's see. Clustering is optimal when you need faster response rate regardless of the internal storage and IO cost. Yes, IO cost and storage cost both would be add-ons. You are okay with it, then go for clusters. I mean, manually we can define some cluster keys. Or your improved query performance offsets the credits required to cluster and maintain the tables. In either of these two cases, you can definitely go for the clusters. Now, what is this clustering key? I said a clustering key here, right? What exactly it is? It is a column or a set of columns. Clustering key is a column or a set of columns. Okay, it is a column or a set of columns in the table, or it can be expressions also that are explicitly designed or designated to co-locate the data in the table in same micro partition. For example, all 2001 data, one or more partitions, all 2002, say all 2004 data, another partitions, all 2010 column values, another partition, so on it continues. Okay, with this information, this is useful for very large tables when ordering an ideal at the time of data was inserted or loaded, or extensive DML has caused tables natural clustering to degrade. Natural means the inbuilt default clustering is degraded. In such a case, yes, better to have this kind of clustering keys. Okay, with this information, general indicators that determine whether to define a cluster key for a particular table or not. How we decide it? Let's see. Okay, so for this purpose, two different important ingredients. Okay, two different important ingredients. Observe carefully here. Number one, two different considerations. Queries on the table are running slower than expected or have noticeably degraded over time, and the clustering depth of the table is very, very large. In either of these cases, you go for the cluster key. Now, what do we mean by cluster depth? Let's put this way. Assume, for example, I'll just take a small example here. Assume you have a table with you. Say, for example, A and 100. Or I'll put this way. For example, I'll take it as ID, name, and year and quantity. Okay, ID, name, or I'll say, for example, P1 2001 and quantity 9999, like this. 1002 product 2 same 2001 and something like this. Okay, so here it is. You got multiple values like this. Say 2003, I'll just enter this way. 2003 product 3 2001 and 7777, like this. Same way, for example, 1004 and product 4 2001 and 6666. Now what I'll do is I'll simply get some values like this. 2001, 2002. Say for time being, you got some values like this. Okay, so product 5, product 6, and you got product 7 and product 8. 2001, then 2002 here, right? This is 2002. This 2002 continues like this. Now from here, say you would like to partition based on year. Say you would like to partition based on year. Then here it is. All this content can be one partition and this would be another partition, right? Like this. See here in this way. For now, you would like to search for a value called 9999. you would like to search for a particular value called 9999. There are two things to consider. One is depth, other one overlap. Depth is here the number of partitions, 2, because 9999 is in 2 partitions, and there is one overlap because it is repeated in other partition also. For example, assume here it is 8888 is in 3 partitions. Depth is the number of partitions, 2 overlap. Number of extra partitions, it is, yes, it's already there in one partition, it's again another partition, that is overlap 1. I mean, as per the definition, okay, as per the definition, here it is. Back to our notes. Depth means the number of partitions that need to be scanned to search for a particular value like 9999, 8888, etc. Overlap, number of additional partitions that needs to be scanned to search for a particular value. Number of extra partitions you would like to scan. So overlap means in addition to the current partition, you need to additionally scan other partition also. That is called overlap. A cluster key can be defined at table creation time or during table creation, okay, or later afterwards using alter table command, and can be dropped any point of time. Let's understand how to define this important aspect. Before we proceed, the main benefits of clustering key. Yes, number 1, scan efficiency, performance. Number 2, better column compression. And after a key has been defined on the table, we need not worry about additional administration activities. Everything your Snowflake service layer will take care. And considerations for choosing cluster for a particular table. If a table have more number of partitions, micro-partitions, or more number of conditional queries, the queries are simply there are more frequent column based conditions, or the queries are frequently sorting the data, or high percentage of queries may benefit from the same clustering keys. In all these aspects, in all these cases, automatically the clustering activities will be taken place. Or in all these cases, we can implement clusters. And after we define clusters, what next? We need to understand the reclustering activities. So as DML operations, insert, update, delete, merge, etc., as these operations are performed on the cluster tables, the data in the tables might become less clustered. So periodic or regular reclustering of table is required. So during reclustering activities, Snowflake uses the cluster key. It uses the cluster key for a clustered table to reorganize the column data. What if you don't mention this cluster key? Yes, in such a case, additional management is required, remember. So if you define composite cluster key, then few additional overhead activities may be involved. Like for example, the order also has an impact. So first column is supposed to be integer column, not a rule but recommended practice. Okay, next. Apart from this, defining a clustering key directly on top variant column is not supported. Remember, variant is one of the preferred data type. We don't know the type of data, then we go for variant data type. On such columns, it's not recommended, it's not possible to go for the cluster setup. With this information, next, too many micro partitions may degrade the performance of the queries. And internal partition type, either you define the cluster key, or just leave it as it is. Either define the cluster key or leave it as it is. Either of them automatically. There are three important partition styles: list, range, and hash. List partition are performed based on distinct column values or distinct values of a column. Same way, here range partitions performed based on set of values. Okay, next. Same way here we have hash partition based on column and value conditions. Okay, so here it is. So we have list partition. Number 2, range partition. Number 3, hash partition. 3 different partition styles. One of them will be implemented automatically. And during table creation, if we don't specify the key column, clustered key column, Snowflake will auto partition based on such column that has more number of unique values. So by default, it is list partition by default. To specify the partition key, we need to say create table clustered by and the column name or set of columns. Observe carefully here. With this information, let's understand now the practice part. How to create the partitions with cluster activities. Okay, so here we go. For example, let's take this one. Yes, here it is. How to create a table with clustering key. Create or replace table cluster by this one. So let's log into the Snowflake. Connect to any database of your choice. Okay, connect to any database of your choice. And then from here, let's understand how to implement the partitions. Let's see. Simple, straightforward activity. So for this purpose, I'll simply go to worksheets. I'll select DB1, go to worksheet and plus worksheet. So there is one database called DB1. Okay, so here it is. Let's connect to the database called DB1. We just verified it. Public or any other schema. So let's go to public schema, db1.public, and here it is. Create or replace table T1 clustered by column. See here, clustered by column. Okay, then click run. Just click run. Either you go for the default snow site or it can be the legacy console. Okay, either of them the same concept. Or you can alter cluster, alter table name by alter table name clustered by multiple columns. Here actually we are supposed to have col1 comma or col2 of type integer. Let's put this way. Then it is recommended to have col2 first, then col1 next. Priority matters when order of values matter. So create table1. Okay, minor modification to our example. Yes, so here it is. Firstly create table. Firstly you create table name and run it. Cluster by column, and same way later point of time, yes, we can modify the cluster property. So alter table name cluster by, like this. Next, same way, how to define cluster partition based on one or more columns. So this is actual example, and with expressions. In our theory part few moments back we learned we can have a column or set of columns or with expressions. So create table name. See here, substring of one column to date of other column. Have a look at it now. I mean, we are doing two things. Number one, clustering activities. Number two, computation. So computation first, then clustering next. Then we have other one. Say for example, this is my table 2. Okay. Same way, alter table 1, drop clustering key, like this. So cluster by, this is the keyword to define the cluster. Okay, cluster by we call this one. Whereas to remove an existing clustered column from the table, this is clustering key. We'll say clustering key. So here it is. Alter table name, drop by clustering key, like this. Observe carefully. So with this information, yes, we are understanding how to define cluster on a particular table, or alter the cluster or remove the cluster. Okay, you'll practice these items carefully. And one more important thing, how to verify the clustering information of a particular table. You are given a table and we know it is clustered, or you would like to verify whether it is correctly clustered or not. Then select system dollar clustering underscore information. Here it is. Click run, and here it is the information like this. Okay, so here this is the complete data. Double click and you see the entire information here. So this is the complete information. You can copy, click to copy and give it to a notepad to analyze the content. Here it is, cluster by keys. Here you see the type, like is it linear or range, right? You got 3 different styles. List or linear or range or hash. List is also called linear. And next, you got the columns involved in the clustering key, total partition count, constant count, etc. By default it is 0. Okay, now you start inserting some values. You see the overlaps, depths, etc. Very important. If the overlaps are more than 100, Okay, if the number of partitions are beyond 100, it's recommended to always change the partition key column. Okay, it's important to understand. So with this information, we learned how to define partitions, how to modify the partitions, and how to verify or audit the partition activities. With this, we'll stop for now. You practice these items carefully and use me for your doubts and clarifications. Kindly make sure you refer to the notes carefully and complete your practice. Do let me know for questions, clarifications, if any. Thank you very much. Have a nice time.